Hello everybody, welcome to science. Hello, how are we doing today? Good morning, how are we? How is the cold treating everybody? Hopefully you're nice and warm wherever you're at. Your internet is bad. What did it do? Why is it so bad? You're good, Em? That's good. I replied to your message, Em. I don't know if you had a chance to look at it, but you can check it out after class. Good morning, Jess. Good. Your audio isn't working. Well, that's not going to be good. So, okay, good. Thanks, Em. Is it not work? Sorry, I'm just going to send a message to Luna to find out what's going on there. Okay, Christiana's having trouble with Blackboard. There's a whole bunch of tech stuff going on today. Must be the cold. The world is freezing over. You cannot handle all of this. It's like, it's too cold. It's fixed? Okay, good. Thanks, Luna. So you're good to hear. Excellent. And Christiana is here. Looks like she's on now, so that's good. Good. Awesome. Oh, you know what, Caitlin? You're just rubbing our noses in it. So sad. So sad. Awesome. Good. So we had fun. I'm speaking for everybody because I had a lot of fun. On Monday when we had everyone came into the labs, it was such a good time. It was just fun watching everyone laugh and kind of scream when balloons popped, and we had fire and we had things exploding, and it was good. So I don't know about you guys. Did you guys have fun, the ones that were able to make it? It kind of was crappy for the people that watched because you weren't able to join in. So yeah, the fire was fun. Yeah. There were no guys, actually. No, it was all females, but I had some people online that were watching. So, and just kind of staying on that note, so there was a few of you guys that didn't even log in to the live classroom that day. So you guys need to make a point of either attending the session or logging into the live classroom, unless I say otherwise, unless I say there's no live classroom, either here or you're, whatever. But there was quite a few of you that didn't. So that's something that you guys have to make sure that you're doing. Communicate with me and say, because most of you guys make classes, so Monday I should have expected almost the same amount of people to be attending either in person or, sorry, one thing I just remembered to do, attending in person or actually coming online. So we really just need to make sure we're doing that, okay? No, and that's fine. Like if there's a reason why you couldn't make it, that's fine, but you should have, I'm just saying everyone should have been either live or in person. So, and some people just weren't on either of those, so yeah. Good. Okay. I was really confused on how it worked. I thought there was a separate, oh, yeah, no, that's fine. So just shoot a message. Try not to do it the morning of. So when we're doing things like that, like most of the time in those mornings, especially when I'm setting up science labs and stuff, I don't even have time to look at my messages. So a lot of times, see if you guys can pre-think questions or or see if you can message each other and they can help you out with that. So that's something that you guys can do as well. All right. So I am missing still a few people today. Yeah, you better, Luna. You better. Watching you. Okay. All right. So today we have Chemical Bob, and he's made some reactions and some spontaneous combustion. Because he had same socks. Yep, stinky. All right. So today is going to be kind of a mellower class, which is good. Give you guys some time to get some work done. Not gonna lie, those clouds. You're funny. Oh, I think the sun's getting to you. All right, so we're at the end of this week, and Friday's professional development day, so us learning. And then so next week we have Wednesday the art lesson, and Friday is the water park, so that'll be fun at the H2O. So that will be entertaining. So today's plan, we're just going to review chemical changes. So that's stuff that you would have learned many years. Like I know I taught it in grade 7, so it's something that's probably been touched upon a little bit along the way in your science classes. So we're just going to do a quick review of that. I'm going to get you guys to watch a little video clip, and then we're going to play Battleship, and then your assignment that will be due like basically a week and a half from now will be a lab. So I'm going to give you guys a little bit of time to work on that. So yeah, so that's the plan. So there's no notes to take for this. I just want to do a little review. I do expect some interaction. I'm going to ask you guys some questions along the way just to make sure that we are all thinking the same thing. So just some reminders. Matter is anything that has mass and takes up space, basically volume. So that is something I think you learned in like grade 4 or 5, something like that. So that's a while ago. So does anyone remember how the chart lays out when you're talking about matter? Does anyone remember what the 2 next little subsections are? If I was to take matter and then split it into 2, does anyone remember what those 2 ones are at all? It gets split into 2 categories. One is a 2, where a P and an S is on this one side, and then the other one is an M. You're funny. No, not that. It gets divided into, if I told you the one is mixtures, the other one is a PS. 2 words, first word is a P, second word is an S. So one's mixtures, the other one is, oh come on guys, you had to have learned this. KUT. Starts with a P, the first word, the second word starts with an S. Not solids. There's 2, it's a 2-word thing. It's talking about one concept, PS. Oh my gosh, I'm glad we're going over this. Some people are typing, so I'm just seeing if anyone is going to get it here. So it's mixtures, and if I said the first word is pure, does anyone know what the word next to it is with an S? Pure with an S? Yeah, Jelena, she wins the prize! Or she typed faster than the rest of you guys. Okay, I knew we were going to get there. All right, so then if we have pure substances, it splits into 2. So if it's a pure substance, one of them starts with an E, one of them starts with a C. Does anyone remember what those are? You should be able to get those because we've been using these words. We've actually been using these words in this unit. So one's an E. Think about the periodic table. One starts with an E. Come on, you guys. Come on. Yes! Elements and compounds. Excellent. And then the other side, my graph is only showing 2, but there's actually 3. I'm going to show you this graph. I should have put a different one on. There are 3 of them. So if we had a mixture, it can get separated into 3. Does anyone know what any of those are? 2 of them start with an S, and the other one starts with an M. Think about orange juice and muddy water and oil and vinegar-ish. What happens when you shake them up and mix them and let them sit? What is that called? Starts with an S. All of those are examples of something, a certain type of mixture. They separate each other exactly. So what's that called? Starts with an S, but that was a close, kind of on the right track there. Does anyone remember? S-U. We don't know. It's a suspension. So it's a suspension when you mix things together. So if you took muddy water, shook it up, it would look like one solid, gross-looking color water. And then if you let it sit, eventually the particles and the sand, the dirt, everything like that would settle to the bottom, and the top would be the water. And same thing with orange juice. A lot of it you have to shake and stuff like that. So those are called suspensions. What are the ones that are like apple juice and tea and all those ones where I put a couple things together, it looks like one thing, but then it doesn't separate if I let it sit. It's going to stay like that. That's an SO. Regulars. You're funny. Not regulars. So, yes! Oh, Angelina, you're going to win some prizes here. And Jess got some. Yeah, so it's solution. Good. And then what's the one where, like the snack that's like nuts and bolts and stuff like that, where you can pick things out of it. If I opened up a drawer and it has like a whole bunch of pieces of metal and pencils and erasers and all this kind of stuff, and I can pick them out, it's called some kind of mixture. So we have the mixture, which is good, but it's some kind of mixture. It starts with an M. And Caitlin just joined us. What kind of mixture? We are playing a game. It's such a game. We're having so much fun with this game. It's called a MOOC. If I was to do something like a robot, I was like, and I'm made of parts and stuff. It's a kind of, and I can manually pick things out. Yeah, Sean. Boom. Mechanical mixture. Okay, good. So, so suspensions are missing on the mixture side. Whew! Well, that took us a while, didn't it? Okay, so we have matter separated into pure substances, which also goes into elements, and that's the basic stuff you see on the periodic table. Compounds are when we combine those elements together. And then we have the mixtures, and we have solutions, mechanical solutions, so that's stuff that never separates, but it looks like one thing. And then we have mechanical mixtures where you can see the pieces and take them out. That's just like Fruit Loops, you can take all the color pieces out, or Lucky Charms, you can take the marshmallows out and stuff, because that's the best part of it. Or a suspension, just like orange juice or muddy water. Tomato juice is like that too. All right, good. Whew, that was a little scary. All right, so matter. We can describe matter as how its physical properties are. So we can look at things about its color, taste, density. So we can describe different types of matter according to those things. We can also look at its chemical properties. So we can look at what happens when we add heat to it, if we do any kind of mix it with something else, cause certain reactions, that sort of stuff. So when they are trying to identify something that's unknown, they will use these kind of properties to start sorting it out. So maybe the first thing they'll do, they'll say, okay, color, it's black, it automatically goes over here, and there's 5 choices, okay? So then what could be the 5 choices? Well, it's very soft, so that narrows it down to 2 things. And it's like, okay, and now the 2 things are almost identical except for what happens when you put them in water. Well, let's put it in water. So they put it in water, and then they check the reaction, and that usually helps them identify the products and stuff like that. Yes, they do taste the same as far as I know. Yeah, I think they do taste the same. However, it's not like that with Smarties. Smarties do taste different. Okay, so that is what matter is. So we're going to look, just a quick reminder of what physical change is, because any kind of change that happens with matter can be physical or chemical, all right? So with physical change, there is nothing new that happens. So it is usually something that what we started with is what we're ending with. Nothing new, nothing happened that. So for example, going from water to ice, there's no new product. All we did was change its physical state. That's all we did. And we can actually usually reverse them. The word usually is really big, because some of them might seem impossible to reverse, but it's just basically just something happened differently to change the way it looks. So they kind of consider that reversible, sort of. So in this case, with water, you can turn water to ice and ice back to water, so it is reversible that way. Ripping a paper technically is just a physical change, because you're just changing the way the paper looked. Once it was one whole sheet, and now it's 2 sheets, right? It has a jagged edge. They consider that, like, that's the sort of usually reversible one, because I could tape it back together, or we could like mix it all back together and pulp it back and then make a brand new sheet of paper. So that's kind of what they mean by that. Once it was a tree and now it's something we draw on. Yes. And then we have some melting ice, dissolving salt. All that stuff is just physical changes. Okay, so they're just basically, we just took a pencil, broke it, physical change. I broke a piece of glass, physical change. I melted ice, physical change. That's what all those things are. Okay, so then we get to chemical change, and there's usually something has happened. Something new was produced is typically what goes on. And we're going to spend the next couple lessons looking at chemical change, specifically what happens during a chemical reaction. And so when we have this, usually it's very hard to reverse it, all right? So for example, the one that a lot of people talk about is the egg. Once you fry an egg, it's, you know, impossible to reverse it. Once you burn firewood, it's impossible to reverse it. Once you set off a firework, it's impossible to reverse it. So all of those are examples of chemical change. So what I want you to do, what I want you to do right now is I want you to go to the Moodle site, and there is a link there for you. Let me just show you, because I can. Where are we? Oh, yeah, there we go. It's called Unboil. Oh, that should be Unboil an Egg. Should be and egg. And it says a link there. So what I want you guys to do, I'm going to fix that right now. And it does that to me every time. I should know better. I don't know why I did that. There we go. So I want you guys to go to that link, and stupid Miss Mac cannot remember how long the video is. So she's going to click on it, and 4 minutes. So I'm going to give you guys 5 minutes. Okay, so 5 minutes to go watch that, and we will be back. Okay. All right, welcome back. Hi. So isn't that interesting? So what are your guys' thoughts? What do you guys think about what you just watched there? I was kind of excited when I saw that because I was like, oh, that's kind of neat. But yeah, because we always believe that you can't do that. Yeah, perfect. Yeah, and so Magical Merle and I were just talking, and we're like, why would you want to do that though? And the thing is, like, they're probably going, well, if we could do that with this, we can maybe do it with this and apply it to something else. Yes, it's really interesting about the eggs, right? Yeah, it's very entertaining. Yeah, that's his new special name. So, okay, so that is, I'm going to go back to the presentation. That is just one of the things that they use to look at for chemical change is that usually it's almost impossible or hard to reverse. So there's a few other ones. Does anyone remember anything else? There's technically like 5 things, clues that it was a chemical change. Does anyone remember some of them? What are they? I'm going to give you guys a few seconds. If you can remember, just type them in and see what you guys can come up, because there's about 4 other ones that, that are clues that a chemical change has happened. There's 5 others. There's 4 more, but I've split them up into 5. But color change, new substance, heat, very nice. Good. Smell, very nice. Are you saying you smell or I smell, or what are you saying there, Jess? I'm just kidding. I'm just kidding. Yeah, smell. Anything else? Anyone can think of something? You guys did really well there. You're doing better at this part than trying to figure out the whole graph thing. The chart, that's good. Sometimes steam and things, yes. So steam would usually kind of be thought of as kind of heat and stuff like that. Perfect, good, you guys did well there. So 5 clues, and like I said, it's technically 4, I've split them into 5, but that a chemical change has occurred. So a new color appears. So when you do mixing, add something in or whatever it is, then all of a sudden there's a new color. So you can see he's putting red into yellow, and you can see that there's an orange happening. They mixed colors. We got like a purple and a brown happening as well. So that's the first clue. Usually there's a new color, and Luna had mentioned that, so that is perfect. You get some online high fives. All right. Number 2, heat or light is given off, or it could be actually absorbed too. That's another part of it. So a lot of times like fire, flame, fireworks, heat and stuff is a digital cookie. I gave a digital high 5. No cookies, 5. And so usually there's that. And I think, yeah, Luna, you mentioned that, and Jocelyn, you mentioned that. So heat, light is coming off. So not only just heat, it could be light as well. So there might not be any heat, but just light. That changes. And you can have gas. Yeah, you got some bubbles going on. Yeah. So when something starts bubbling, can you guys think of something that you guys typically drink that when you open it up, it bubbles? Yeah, pop soda, all that kind of stuff. That's a chemical reaction that's happening, right? You're releasing, it's bubbling because you're releasing the carbon dioxide and stuff that's in there, right? So that's a chemical reaction, so that's all exciting. A new solid precipitate, I said the wrong word there, sorry, precipitate. This one's really cool. I've done this, actually showed this with my grade 7s. And when you mix a chemical, a couple things together, and what's really cool, if you look at the right one, that's sort of what I did. You have a couple clear things, you put them in there, and all of a sudden like a solid forms in it. It's really, really neat. So those are some fun chemical experiments that you get to do when you get to create them. Sometimes it makes like a little weird wormy thing as it pours in. It kind of creates a solid worm and everything. So, but that stuff you would have done in previous science things. We're past that. We're so past that. Yeah, I don't know. What did I use? Oh, I'd have to go look. I haven't done that in a year now, so I can't remember. And then the last one is a new odor. So, so Jess was saying that she smells today, but if we went off of what Jess said, then we're talking about that odor can be. I'm just kidding, Jess. So yeah, so new odor. So a lot of times, when I said I've taken 2 of them and split them, a lot of times they'll say a gas or a smell comes off, so they'll combine, they'll combine 3 and 5 together and make it 1. So you can look at it as being 6 things, which you include can't reverse and stuff, or make it 5 and put odor and gas together, but not necessarily always the same. So, have you ever done that thing with baking powder? Yes. I think I know what you're talking about. Yes. Okay. I think so, yeah. Awesome. Okay, so we're going to do a little quizzy quiz here. I'm going to get you to tell me what you think. So I will get you guys to, let's do it this way. You're going to put a check mark. I'll just type it in here. So check mark means physical. No, let's say chemical. Chemical. And then we'll do an X means physical. So what I want you guys to do is I want you to put an X if the example I'm going to put on if you think that's a physical change, and if you think it's a chemical change, we're going to put a check mark. All right, ready? Get ready for your checks and your X's. Okay, first one, sugar dissolved in tea. What do we think? Put X's or check marks? What do we think? Sugar dissolved in tea. So think of the 5, 6 things. Did that happen? Is it a physical or chemical change? Good job for the majority. Yeah, it is a physical change. So even though you think it's a color change, it's really not. It's just particles going into each other. And it is something that technically can be reversed. It's very difficult. We're just changing how things are. So we're just mixing some stuff together. Good job on that one. Okay, clear that. Okay, next one. Breaking water up into hydrogen and oxygen. Breaking water up into hydrogen or oxygen, is that a physical change or a chemical change? What do you guys think? I won't let you put an X. Forgot to say thank you. It's almost like an Oilers shirt. Yeah, it's pretty close. All right, so we have a ton of check marks going on here. So you guys think, what is check mark again? Check mark's a chemical. So can someone tell me why you think it's a chemical change? What would make you think, any one of you guys, what would make you think it's a chemical change? What would be the reason for a chemical change? I know it's easy to hit a check mark or to watch what everyone else is doing, but what would be the reason why it would be a chemical change? Come on, guys, talk to me. Why do you think it would be a chemical change? The properties of the molecules change. Nice. Any other thoughts? That's a good one too, because it is explaining the whole idea of what water is, right? So water is a liquid, and it's freezes at this temperature and melts at this temperature, and yada yada yada. It looks like this, and then once you break it up, they're quite different, right? And so it becomes two very distinctive separate things. Good. Good explanation, Belle. Online high five. Okay. Burning a log in a campfire. Burning a log in a campfire. I just booked 2 camping trips coming up, so I'm all excited. That one can be reversed too, right? The water one, which one are we talking? The water one can be reversed. Yes, it can be reversed. Yeah. Yeah. Okay, so burning a log. So we have a log. Think about what it looks like. And when you burn it, what happens? What happens to that log when you burn it? 1, does it change color? Does it change color? Yes, it does. So there's one of your big hints, guys. It's changed color. So if it changes colors, is that chemical or physical? Does heat come off of it? Is there smoke that comes off of it? Light comes off, so it's a chemical. So that one should have been a check mark for most of you guys on that one, because that's a chemical change on that one. Okay. Crushing an aspirin. Crush, crush, crush. Physical or chemical? So chemical is a check mark. X is a physical. Which one? Good. Yes, it is just physical. We're just crushing it. We're making it look different. That's really all we're trying to do with that. Good. Okay. And this one, metal rusting. When metal rusts, is that a physical or chemical change? Which one is that? Okay, so I have a lot of check marks. Good. Yeah, it's definitely a chemical change. We're changing the properties of it. There is a color change, can't reverse rust, that sort of stuff. So that is definitely, it's oxidization is basically what's happening there. Lighter fluid burning. Burning ring of fire. Down, 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 J's head higher. Gotcha, thanks Slade. So what is lighter fluid burning? Is that a chemical, physical? So I got check marks. We're thinking chemical. Exactly. Heat's given off. Usually there's going to be a flameage involved. Perfect. Number 7. Oh, I got it clear. Number 7. An egg rotting. Physical or chemical? Physical or chemical? I might see an interesting answer here. I know, it is really gross. One of the classes I taught at my other school was called crafts, and we actually made Ukrainian eggs and did it actually with the proper tools and everything. And one of the teachers was involved in it, CEA was involved, and she told me the other day that was, oh gosh, 4 years ago, and she broke the egg. She said it stunk so bad because you don't take out the egg, right? You keep the egg in it. Yeah, it's kind of gross. Okay, so we have a mixture here. So, Dean, can you tell me why you think a rotting egg is physical? So Dean, tell me why you think rotting egg is physical. And Bryn, why do you think it's chemical? I'm just going to ask you too, just because you have different responses. And there's a few other different responses there as well. So why would, so Bryn, tell me why you think it's a chemical. And then Dean, why do you think it is a physical change? Just want to see what your thoughts are. Ew, that's gross too. All right. So yeah, so we have, it's not dead even, but we have a little bit of majority with the chemical, but we're kind of close there. Yeah, so Dean, if you think it's chemical, there you go. Okay. All right, so sorry, Jess, could you tell us why you think it's a physical change? Sorry, so Dean just changed his answer. So Jess, why do you think it is a physical change? And so Bryn, because the molecules are breaking up as it rots, okay, so you think that the molecules are changing. So think about the 5 rules. What are those 5 things that would indicate to you that, that there's something going on there? The smell, the color, okay. Thank you. Smell the look of it. Chemical. Okay, good. And Jess, what are your thoughts? Oh, Jess, everyone's changing their answers now. Oh, you guys. Okay, this is a chemical change. It does have a smell, and there is some, definitely some chemical changes happening. So it's just like what's kind of happens in your stomach. You have acids and stuff that interact. Here you have bacteria getting involved and doing certain things and changing the chemical makeup of it. So all that kind of stuff. So yeah. Number 8, boiling water, physical or chemical change? Physical or chemical change? That's an interesting story, Katie. All right. Physical or chemical changes, check marks or X's. So check mark is a chemical and physical is an X. Physical, chemical, which one do you guys think it is? So we have, oh, we're close again. Katie P, you're not voting. Lindsay, I don't know where Lindsay went. Sean, Slade, how come you guys aren't voting? Chemical, physical. It doesn't matter if you're not right or wrong. I'm not doing anything. Yeah, no problem, Slade. I saw that, yeah. Sean, did Sean leave? Sean, if you left, you always have to make sure you put away. Good. So the majority, what number is that? I can't see that far. Most of the majority put physical, so it is a physical because you boil water, you can freeze it, you can turn it back to it. And last one, look at the test tube. So look at the image in the test tube. Oh, sorry, there we go. Thank you, Magic Merle. What is happening there? Physical or chemical change? Miss Mac is going to yes, I know. Banish. All right. Physical or chemical change, if you look at what is happening there. Everybody needs to vote. You're allowed to get it wrong. I'm not going to beat you. I'm not going to do anything. You're okay. What do you think? So think of the 5 things: smell, color, odor, new substance, all that kind of stuff. Bubbles. My bubbles. My bubbles. All right. KDP and Sean must be having issues because they're not doing anything, I'm thinking so. There is no both, because it is no both. It is, this is going to be a chemical change. So we have change in color is happening. And it's hard to tell, but if you look at the right one, there's a little bit of bubbles. Bubbles, bubbles, bubbles going on. Excellent! Okay, we're done. Quiz is over. Good job. That's okay. All right. You sunk my battleship. It's on like Donkey Kong. All right, we're going to play some Battleship. So, now, some of you have not done your homework, so we are going to work with that. And what I want you guys to do, and I did send you guys a message making sure that you knew we were doing this. So with the Battleship, I am going to go over how to set this up for you, and then we're going to go over it, make sure you understand what you're doing, and then I'm going to give you guys like 20 minutes to battle and play, and we're going to do that all in breakout rooms. So it's going to be fun. Yeah. Okay, so have your battle sheet out, and I'm just going to go over the instructions, and then I'm going to get you to do it as I do the instructions, okay? So I'll give you a few seconds here. Make sure you guys have that out. You'll probably, I don't know if you want a pen or a pencil. Doesn't matter which one you're using for this. Okay. Yes, so this is the front of the sheet. That's the back of the sheet, right? So it's the same sheet. Yeah, so I'm just going to go over the rules with you. Okay. So you have a player one spot, and that's what we're going. So you guys have already done number one. You guys have already finished it. You guys filled in the chart. Number two is now you got to place, okay, thanks Jess. Now you're going to place your guys on. So what works really well is that no one else is around you, so you don't have to hide this. Like when I do this in my classroom, we have to hide it and everything. So what I want you to do is on the back side where player one is, you're going to mark your ships with an X. You're going to make a ship that is 4 spaces. You're going to make a ship that is 3 spaces and a ship that's 2. You can go diagonal, you can go across, or you can go up and down. Here's the only thing. You can't have a ship go through another ship, okay? So I can't have a ship going like this and then a ship going like that. I can't have it going through the ship. What I can do, if I wanted to, is I can have my 4 ship going like this and then my 3 ship here. So it's not going through it, it's just right next to it. So hopefully you guys can see the difference between bad and good. Okay, so what I want you to do, player one, which is right here, put in where you want to put your guys. So I'm going to put 1 there, I'm going to put 1 there, and I'm going to put my 2 right there, or something like that. Okay, so quickly decide where you want to put them on your sheet of paper. If you don't have the sheet of paper printed out, draw the grid. So you'll have 1, 2, 3, 4, 5, 6, 7. You'll have 8 this way. 1, 2, 3, 4, 5, 6, and 8. Yeah, so it's 8 by 8, 64 grid. Okay, so you can just draw that out, and you can still play without having the stuff with you. Okay. Actually, I'll just stay on here. Okay, so I'm assuming everyone was able to put that many X's down there. So now the step number 3, it says in order to hit your partnership, you must make an ionic compound. So that's where the 2 things join up. Okay, so you're going to take the element that's on the left, and you're going to take the polyatomic ion that's on the top, join them together. Okay, so you're going to call out the name of that compound. So what we're going to do, and I maybe do it on player 1, that might be easiest for you. What I want you to do, if you don't know what the names of them are, so say for example, like I know Li is lithium, right? Because it almost looks like the word, right? And most of us know H is hydrogen. So what we're going to do is just make sure we understand what each one of these are actually called. Okay, so you can do like little notes on the ones that you don't know, and then it'll help you kind of talking about it. So this is the part that I said I'm going to help you out. If you didn't do your homework, this will help you out here. So what is the H1 called, guys? What is the H1 called? Hydrogen. Perfect. Good. And what is the Cu1 called? Copper. Okay, so if you need to, you can just write copper here, just in case you need to write that down, so that when you're calling your battleship cards, you know what it is. The ones we wrote in player one. We haven't wrote, the only thing we've done is shown where our ships are in player one, Jocelyn. We haven't done anything further than that. So don't go ahead of me. We're not doing anything yet. Okay, so let's just stick with me here and then we'll go. So we're just doing the names. What is FE, guys? Those are, well, they have to be your ships. If you're drawing them on there, whose all ships are those? Those have to be your ships. Okay, what iron? Good. So Fe is iron. Li, we just said was lithium. No, you don't even have a partner yet. So you no. Oh, Jocelyn, you've never played Battleship, have you? I don't think you've played that before. It's okay. I'll teach you. So we'll just go with this. Yeah, this is where you were putting your ships, right? Good. So Li is lithium. What is Na? What is Na? Sodium. Good. What is K? What is K? Potassium. Perfect. And the last one, Sn. What is Sn? So I told you guys to have that sheet of paper in front of you. So remember the sheet of paper I had? I don't know if you can zoom in, Magical Merle, to that. This was the sheet of paper that I said that you guys should print off for me. It is the one that has the periodic table on it. It is the one that tells you the charges on it. And then on the back, it has all of the polyatomic ions on it. It has the Roman numerals, and it has, when you're doing two non-metals, like the prefixes like di and tri and all that kind of stuff. This is what is considered the cheat sheet. This is one of the things I asked you to print off. You should have this with you every time we're doing anything with chemistry, okay? So a lot of you guys should have been able to find where Sn is and find it as tin. Excellent. Okay, so we've done the left side. We've named what they are. So now we're going to do the polyatomic ions, and that's why this sheet's important, because it tells you here. So when I did this, all I did was look at the sheet. I don't have those all memorized. I don't want to memorize those. So I went and looked and went, oh, okay, that's what, oh, what just happened there? He's making this all fun. So with the polyatomic ions, we're going to write them in. So people that don't have the sheet, you're just going to have to go with us here. So what is OH? So if you look at the polyatomic, what is OH? What is OH? Hydroxide, exactly. Okay, so OH is hydroxide. So if I was to combine the H and the OH, that would be, it would end up being HOH. Okay, so that's what you guys were supposed to do in player 2, was to combine the element hydrogen and the polyatomic ion of hydroxide, put them together and write the new chemical formula. So that's what you guys were supposed to do for player 2 for your homework. All right, what is NO3? What is NO3? What is that one? Nitrate. Good. Make sure it's ATE at the end, because there's a few different ones that have different endings. Remember we talked about how many oxygen atoms there are. It changes the name, usually the ending. You moved all your ships. Next one, SO4. What is SO4? Sulfate. Perfect. Yeah. Good, good. And CiO3. What is CiO3? Good. Chlorate. Perfect. Yeah. So jot these down, because when you are playing Battleship, you're going to actually have to say, do you have part of your ship at iron and sulfate? And so when I say that, iron and sulfate, when I say that, I'm talking about this square right here. Okay? So that you're going to be using those coordinates, the element and the polyatomic ion, as coordinates. Okay? So NO3 was nitrate. Nitrate, Jocelyn. Okay, so we just did CiO3, chlorate, good. What is HCO3? Bicarbonate, yes. I was looking for that in our chemical room yesterday and we did not have it. So actually I was looking for, this is what I was looking for, this one. I was looking for this guy in our chemical formula and I couldn't find it. I was looking for sodium bicarbonate, but we did not have it, so I might have to order some. Okay, CO3. What is CO3? Good, so it's just carbonate, so it's not bicarbonate, it is just carbonate, okay? And the last one, PO4. Yeah, phosphate. Good. So what you guys should have done now is written in what you need. The top ones, you probably should have written most of those in because I don't know if you have those memorized. Or you can just refer to your sheet of paper. You can totally do that. The side ones, you might know some of those without actually having to write them down, but you totally could have. Sorry, I have a fluff. All right, so that was that step. So step number, so I just showed you an example. So here, if I wanted to see if someone had a ship there, I say, do you have anything at iron? And what was that? Nitrate, chlorate, sulfate. And then they would say hit or miss or something. And then I would go, do you have something at sodium and bicarbonate, and they'd say hit or miss, okay? So this is how it works. So number 4, I'm reading instruction number 4. You will record your hits and misses on the player 2 game chart, okay? So you're going to go down here to your player 2, and it's full of a whole bunch of words and stuff, and you're going to record where you hit and where you miss. So let's say I called, which one do I want to call? Let's go copper hydroxide. So let's say I did this and they're like, no, it's a miss. I'm going to put an M here. And because you have words and stuff there, maybe you're just going to put a little M in the corner, or you can write on top of it. I don't care because I'm not going to look at it again. Okay. And then let's say I ask this one, and I'm going to put an H here, and then I'm going to put an H here, but then all of a sudden that's a miss and all that kind of stuff. So player 2 is where you're going to record down what you ask and what you hit and miss. Okay. Everyone get that? Is anyone confused by that? Good? Okay. So then it says, so if you hit your opponents, you mark an H. If you hit a miss, if it's a miss, you put an M, okay? Now, the opponent gets to go, okay? So let's say Jocelyn and I are playing. So I asked this one, and she said, no, it's a miss. So now it's Jocelyn's turn. She is now going to try to guess where mine are. So here are mine right now. So this is where mine are, and Jocelyn's goes, Miss Mac, do you have something at potassium phosphate? So I go and look at potassium phosphate. Oh, I actually didn't even notice I did. And I say, yes, I do. So on her sheet, she's going to go to player 2, and on her sheet, she'll write an H. Okay, so that's her sheet. But that's not what I'm doing. So here I have the option, so I'm going to make this optional. Sometimes it's nice to keep track of what they've hit and miss so that, you know, they didn't cheat, or they say, no, I already called that. And also if they said it wrong, you're like, no, 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 you said potassium phosphate, you didn't say potassium nitrate or whatever, right? So what you could do on player 1, this is them, this is your opponent. You could write down that actually Jocelyn did hit me right there. Okay, and then maybe she called something over here. Maybe she thought it was going up and down, so she did an M here. And then maybe she thought this way, so it was a miss there. And then she started going this way, and boom. So then I can say, you just sank my 3er ship. Okay, so player 1 is where your ships are and where they're trying to find them. And you can record theirs hit and misses there. Player 2 is where you're trying to find their ships. Okay, and that is pretty much it. And so like I said, you are trying to find all the ships. So if I was playing with Jocelyn, she needs to find these guys, those guys, and all 3 of them in order to win. Okay? So that's all you are doing. You're taking, let's do tin, which one haven't I called? Let's do tin chlorate. So tin chlorate is this one right here. So that's where I'd look. So that's how you call it. So it's like saying E4. It's just a little bit different. It's tin chlorate. So it's the same kind of thing. Tell them when they sank. No, you don't have to tell them when they sank it, because they start wasting turns seeing if that was maybe the 4. So if I told her she sank my 3er, she would stop looking there, right? But if I didn't tell her that, then she would go over here and waste a turn and do that. So you don't, it's a strategy thing. So I'm very competitive, and so when I played with my brother, I never told him, so. All right, so what we're going to do is I'm going to get you guys to go, I'm going to break you into breakout rooms. You're going to partner up, and you're going to play with your partner. And how many do I have? 1, 2. I think I have an even number, which is perfect. So Lindsay, it's 3 ships. So if you look right here, you make a ship that is 4 spaces long. You make a ship that's 3 spaces long, and you make one that's 2. So if you look at this, there is 1 ship, there's my 2nd ship, and there's my 3rd ship. It's just 3 spaces long. Does that make sense, Lindsay? Just want to double check that. Okay. Slade, I'm not sure, are you quoting me? Yeah, when they sank them all, they'll know when they sank them all because they're going to have their sheet of paper showing 3 H's, 4 H's, and 2 H's. They're going to know when they sank all of yours. If all of a sudden they're like, hey, I just won, you're like, no, you didn't, then somewhere there was a mistake, and you'll just have to try to figure out what it is. So what I'm going to do is I'm going to give you guys permission to talk, and I'm going to give you guys permission to write in the breakout rooms so that you guys can, when you guys are in there, you're able to just talk and say them, or you can type it onto the screen and do that kind of stuff, okay? All right, Miss Mack doesn't do this like Mrs. Ward. She doesn't do this very often, so we're going to see how this goes. So any questions before I send you into the breakout rooms? Any last minute questions? I'm going to give you guys 20 minutes to play. If you finish, you can do another one. So if we finished, I can do a different color and I can erase them or draw it again and put new ones somewhere. You can do that again if you finish, okay? All right, so let's see how Miss Mac does with this. All right, I'm going to divide you guys into groups of 2. And I think I'm going to try this. Okay. So let's see. Are we all in groups of 2? Yes, I think I did it, Magical Merle. Yeah. Okay, mic off. Yeah, I'm just returning them all to the room now. Okay, guys, I am returning you back to the room. I'm sure there's an easy way of doing this. I will have to ask the awesome Mrs. Ward how she returned you all at one time, see if there's a way of doing that. But yay, you guys, that was so fun to listen to. I heard Belle and Lindsay were able to get their mics going. So that was really cool to listen, and then reading you guys' messages and misses and everything, so that was fun. So you guys were speaking chemistry, like that was so great. You're like, I heard sodium bicarbonate and lithium nitrate, and yeah, that was awesome. So, did anyone finish? We gave you 30 minutes, so I extended the time another 10 minutes there. Did anyone finish and sink everyone's battleship? You sunk my battleship. Okay, the reason why I do that is, I don't know, I still have my original battleship from when I was a kid. The electronic version, like it still works. And then on the commercial, the guy goes H5, and he's like, "You sunk my battleship." It's actually part of the commercial, so that's why I do that. But yeah, awesome. Okay, so Lindsay, did you guys finish, Belle and Lindsay? Because I know you're still kind of going. I don't know if you played we're on a second game or not. So yeah, so hopefully you guys were able to see somebody had more hits than the other person. That would be the winner. Winner, chicken dinner. All right, so cool. Yeah, so if you want, you can actually play this and practice putting them together. You can make your own. You can take different elements, and you can keep the same ones there, or keep one of them same, change them, or do whatever. And you can play with somebody at home or there and just kind of get practice putting them together and creating the compounds as a formula and naming them. So yeah, good. Okay, so we're going to wrap things up, and I want to talk about this, and I want to talk about your home assignment. So just a reminder that I know I brought it up on Monday, but we finally have everything confirmed for March 1st to go to KSS, and we want you there at 8:45, and we're going there to, the main priority is that we're going there to do a science lab, and we're going to be working with Mr. Borden and doing it with his class as well, and it's working with what we're doing currently, which is really super cool. And so bring a pencil and just kind of think about, so the people that were here, make sure that you're able to roll up your sleeves or put your hair back if you need to, just in case it could get in the way or knock something or anything like that. So that will be something to worry about, right, Dean? I know you got to put your hair back. It's so long, it gets in the way sometimes. All right, so that's the first. And I gave everyone physically here, you guys got the permission form. The rest of you, it's in a couple places. You need to print that off, get it signed and handed in. I don't think any of you have handed that in yet. So can you guys please start handing that in ASAP, okay? So I need those permission forms handed in. Holy, there is typing going on. Okay. Okay. All right, if you are unable to go, can you just let me know what's going on? See if you can carpool, see if you can figure out the bus schedule, see maybe Sunday night sleepover at someone's house that lives nearby, and then you can come. See if you can figure out a way for things to do that. Send me a message in Moodle, not in Blackboard, about this, because when I go back, I won't be able to, once I close this out, I don't have a way of saving it and stuff like that. So yeah, just do that. Oh, good, Angeline, that's awesome. That'd be kind of fun if she was in the same class that we're going to, but yeah. It will be on live. Magical Merle is going to magically teleport himself over there in his equipment, and we're going to have that as well. So like I said at the beginning of class, you're either there physically or you're on live, okay? So that's your two options for that, okay? Yeah, it'll be good. And then we thought that it'd be nice just to do a quick tour for some of you that might be going to that school, just to see what KSS is like. Oh, that's too bad, yeah, that would be kind of funny if it was. Good. Okay, so yeah, so please try to make arrangements for that. So here's your only home, just in the center multi-purpose area. So it's on the calendar. So always go to the homeroom calendar and see what's happening. It's on there March 1st, and it says to meet in the multi-purpose area there. Yeah. Okay. So some of you guys still owe me some worksheets. You guys remember PE. You got to keep up on the PE. You have logs that you have to be keeping track of. So every week you have to be recording all the physical activity you do for every week and handing those in. Okay. So make sure you're doing that. Some of you guys have like hardly anything done for PE, which is not good. And then catching up on some of your work. Yes, your parents have to sign that form. It's a field trip permission form, so they do have to sign it. That's why I'm giving you the form or having you guys print it off and stuff like that, okay? All right, so you have a home assignment and it's not going to be due for a week and a half. So what I want to do is just show you guys what you're going to be doing. And so it is this guy here. So what you're going to be doing is working on something called conservation of mass. And there are questions here. If you don't know the answer, look it up and write an answer in and we'll go over it together in class and stuff like that. All right, guys, thanks. If you can just stay focused on this to make sure you guys know what you're doing. Oh, the PE logs, if you can. Sorry, I didn't know, Em, what you meant. I thought you meant the other form. Yeah, someone should acknowledge that you are being legit and truthful with what you're saying, even though I trust you guys. Yeah, if you could get someone to sign off, that'd be great. Okay, so here's basically what you're going to be doing. And so Caitlin and Sean, I've already emailed your guys' mom with some of the list of materials so you guys can arrange for that. So what you're going to be doing is a couple different experiments at home using products that typically are in everyone's house. And an open system means that you're not controlling what happens to the products that are created from the experiment. So right now, if I was to open a can of pop, it would be considered an open system because as soon as I open it, that carbon dioxide would go out and I'm not trying to catch it, kind of thing, right? If it was a closed system, I might put a little balloon or a bag and have it tied on, taped on, and then when I open the pop, which would be really hard to do, but when I open the pop, it would capture everything. And so that's called a closed system where everything that you start with, you're capturing everything that you end with, right? So that is what that sort of difference means. And then what you're going to be doing is looking at how mass at the start actually is going to be the same at the end. And that's kind of what we're going to be looking at here. So it's step-by-step instructions. You have a week and a half to perform this. It does involve getting the mass of things. So hopefully you have some way of measuring the mass. If you don't, send me a message and maybe we can arrange, you can come and do the experiment on your own sitting there in one of the rooms there where we did the math help. I can lend you guys, you can use a scale there and you can perform it there. So there is some options there for you if you don't have something at home, or you can go to a friend's, you can borrow it or whatever. There's a whole bunch of solutions that you can find. You just have to put the effort in to try to figure out what you're going to do, okay? Now, when it comes to some of the products, it says beaker because this is literally science language, right? What can you use instead of a beaker? Use a glass, guys, right? So use something that works, right? So just find kind of a match to what you would have at home. Yeah, a balance would be like a scale. Yeah, exactly. Okay. You can't do it without a balance because the whole point of this is conservation of mass. So basically meaning, is it the same before and after? So you're going to have to try to figure something out. Like I said, if you don't have it at home, see if someone has it, borrow it, come in here. Okay. So you have some options to be able to do that. All right. So it's just basically step-by-step instructions. You're going to be doing one twice. You can do one open system, one closed system, and answering some questions after you've done it. So here's just an example of what a closed system would look like. Here is an Erlenmeyer flask, and they've put a balloon on the top to capture anything that escapes so that it's all there, right? So that's just an example. And then you're going to use an effervescent tablet is like Alka-Seltzer. So people that were here on Monday, we used Alka-Seltzer with the dry ice. So anything like that would work. Okay, so that's what that means. Erlenmeyer flask is this guy. If you don't have one, you figure out a way of working around that. Find something else. Okay, and yeah, and then there's questions, and that is it. That is all. Okay, so that is a week and a half. You guys got lots of time. If you do need to come in, please just send me a message just to make sure, because sometimes we have meetings after lunch, or I already have something going on. So just always make sure that to communicate with me, and I can say, oh, I'm not there, but someone can make sure you're good to go or something. All right. So yeah, so it's a really fun thing you get to do. You get to see what happens when you put a couple things together. So it's kind of funny, Belle, you were bringing up water and baking soda and stuff. So that's sort of part of what we're doing here today. Okay. Okay, so Dean, can you just send your message that you just sent to me, send it in Moodle, just so I have it. And Luna, yeah, so Luna, if you can send me a message saying that you'll just be on live, but also if you guys can try to find a way of arranging it. So if someone wants to reach out to Luna and say, hey, why don't we pick you up? We can come and pick you up, or why don't you stay over on Sunday night, or no, what day is that? That's, the first is a Thursday. It's a Thursday, the first? Or is that a Wednesday? Anyways, whatever. See if you can stay over the night before or whatever. So yeah, it's a Thursday thing, Sam. So yeah, so see if you can stay over Wednesday night or anything. So yeah, anything can do that. Okay? All right, so that is that. So you guys have a lot of time to get this done, and you have some time to get some of the other assignments done, and make sure you're staying up on your PE. And I'm going to throw a foods plug out there. Make sure you're staying on top of your foods as well. All right, so other than that, ladies and gentlemen, yeah, thanks, Luna. Love for you to get to know some people, Luna, when we start doing some things. That will be nice for you to come out to some of the field trips and everything. So, all right, have a good one, guys. I hope you enjoyed Battleship, and I will see you next week. Bye-bye.